Hello everybody, कैसे हो आप सब? So today we gonna to do JEE Main's PIQ questions from the topic capacitor, right? So this is the first question from the JEE Main's 2026 asking 4 April shift 1. So in this question, what they are asking that a parallel plate capacitor, air capacitor is connected to a battery. So we have to draw the parallel plate air capacitor. This is the parallel plate air capacitor. The plates are pulled apart at a uniform speed V. Okay, plates are pulled apart means plates are pulling apart with speed v. If x is the separation between the plates at any instant, then the time rate of change of electrostatic energy of the capacitor is proportional to x to the power alpha, where we have to find the alpha. So my friend, in this question they are asking du by dt. What is du? What is du is just the electrostatic energy stored inside the capacitor, right? So what is the magnitude of energy stored inside the capacitor? So E is equal to half C square of potential, right? Okay, so they are asking nothing du by dt in this question they are asking. So we have to differentiate this quantity. So okay, if you have to write the capacitance of parallel plate capacitance, so how will you write the capacitance of parallel plate capacitor? Okay, so we know that C is equal to A epsilon naught by D. D is the separation, A is the area of plate of capacitor, right? A is the area of plate of capacitor, epsilon is the permittivity of free space, and D is the distance and separation between the plates of capacitor. Okay, so I can write, okay, 1 by 2 is the constant, A epsilon naught by x, because separation in the question is given as x. Okay, upon into v square, whole things have to differentiate. Okay, right? So A epsilon naught and potential square of potential is comes out to be box. So du by dt is nothing. Du by dt further can be written as du by dt is A epsilon naught by 2 v square. We have to differentiate by dt. If you have to differentiate 1 upon x with respect to dt, so you will get 1 upon epsilon naught v square by 2 into x to the power minus 2, and minus you have to take out the outside of the box. So du by dt, rate of change of electrostatic energy, is directly proportional to x to the power minus 2, and here alpha, comparing the both things, you will get x is equal to minus 2. Okay, right? Now coming to next question. In this question, okay, they have given some statement, and okay, you have to tell us or write the correct statement in this question. So statement first is, effective capacitance of a series combination of a capacitor is always smaller than the smallest capacitance of the capacitor in the combination. In this question they are asking that the effective capacitance of capacitor in series combination is smaller than the smallest capacitor of the capacitance of the capacitor in the combination. This is the correct statement, right? Okay, in the series combination we know that C equivalent, 1 upon C equivalent is equal to 1 upon C1, C2, and so on, C3 and so on. Okay, second one is, when a dielectric medium is placed between the charged plates of a capacitor, displacement of the charge cannot occur due to insulation property of the dielectric. That's an incorrect statement. Now coming to statement 3, increasing of area of capacitor or decreasing of the thickness of dielectric is an alternate method to increase the capacitance. This is also correct. A is also correct, B is wrong. Now coming to D, for a point charge, concentric spherical cells center at the location of the charge are equipotential surface. Yeah, that's also correct answer, right? Moving forward, so option number A, C and D is correct. A, C and D only. This is option B is right answer. Right. Now coming to question number next. Okay, in this question, a circuit is given. In this circuit, a battery which is 2.5 volt, 1 ohm resistor, 2 ohm resistor, 3 ohm resistor, and 4 ohm resistor. These all are resistor in a parallel, no problem. Okay, no problem. Now coming to next question. I don't want to. Okay, now coming to this question. The charge stored by capacitor C in the given circuit in the steady state is. So this is the circuit in which they had given that a 2.5 volt battery, 1 ohm resistance, 2 ohm resistance, 3 ohm resistance and 4 ohm resistance, a capacitor and 2 diodes. Okay, one is the reverse bias and another one is the forward bias. What is the reverse bias and what is the forward bias? This topic you will learn in a semiconductor. Reverse bias is nothing. It's diode when N type of diode is connected to the positive terminal and P type of diode is connected to the negative terminal, then it is a reverse bias, and we know that in reverse wire there is no current flow through the circuit, okay, through the wire. Okay, so this one is the P and this one this one N and P. So this is the reverse bias, so no current. And what is the forward bias? In forward bias, P side of a diode is connected to the positive terminal and N side of the diode is connected to the negative terminal of the battery. So this is the forward bias, and we know that in a steady state, forward bias is behave as a plain wire. Okay, it will be converted to the plain wire. Okay, and in steady state, capacitor allows no flow of charge or no flow of current because it's store maximum charge that can be it stored. Okay, so after redrawing this circuit, let me redraw this circuit. This circuit becomes, okay, one battery which is of 2.5 volt. Okay, 1 ohm resistor. Okay, this is the capacitance. In steady state it will be broken. Okay. Okay, now coming to this diode is a reverse bias. So reverse bias diodes will behave like a broken circuit. Okay, now this one is the forward bias. Okay, diode is become a plain wire in the steady state. Okay, allow the current to flow through the, okay, battery. Okay, we have to calculate the charge on the capacitor. So charge on the capacitor, we know that the charge is equal to Q is equal to C by V, capacitance into potential. So we have to find the potential across this capacitor. Okay, now, right? So for capacitance, we have to find the current through this battery. Okay, so for current through the battery, we can write I is equal to V by R equivalent. So R equivalent will be 1 ohm and 4 ohm. This is the 4 ohm. Okay, 1 ohm and 4 ohm. Okay, so V is 2.5 and R equivalent is 5. Right. So current comes out to be 0.5. Okay, and we know that whatever the potential across 4 ohm, that will be equal to the capacitance because both are in series. So here is the potential which is I into R. I is 0.5 and R is 4, which is 2. So capacitance, voltage across capacitance is 2 volt. Right. Okay, 2 volt. So voltage across capacitance is 2 volt. We have to find the charge across capacitance. Charge is equal to CV. Okay, C is given as how much? 5 microfarad. Okay, 5. Okay, potential is given as 2. So 5 into 2, which is 10 microcoulomb, comes out to be answer. Okay, let's check the answer, my friend. Okay, option number C, which is correct, 10. Right. Now coming to the question number, next question. Okay, Using a battery, a 100 picofarad capacitor is charged to 60 volt. Okay, let's write 100 volt capacitor is charged to 60 volt. Right. Okay, and the battery is removed. Then the battery is removed. After that a second uncharged capacitor is connected to the first capacitor in the parallel. If the final voltage across the second capacitor is 20 volt, its capacitance is, okay, we have to find the capacitance of the second capacitor which is connected to the first capacitor. What is the first capacitance? Let me write the first capacitance by C naught. C naught is given as 100 picofarad, no problem. Okay, now it is connected with voltage V naught which is 60 volt. Right. Okay. For this capacitor is charged. After charge, battery is removed, and the second uncharged capacitor is connected to the first capacitor in the parallel. Okay. For example, this is the first capacitor having C naught is connected to the other capacitor which has capacitance C. Okay, now we have to find the potential across this capacitor. So I can write V nu, which can be V dash is equal to C naught V, okay, original charge upon capacitance, total capacitance. Okay, original charge upon total capacitance, C naught plus C. Okay, so V dash in the question is given as a 20 volt, right? So 20 is equal to C naught. What is the C naught? What is the value of C naught? C naught is given as 100 picofarad. 100 picofarad. Okay, C naught is given as 100 picofarad. Okay, into original voltage is 60 volt. This is the 60 volt. What is C naught? What is the C naught? In the question C naught they are given 100 picofarad. No problem. Okay, and we have to calculate this C. This C we have to calculate. So I can write, okay, I have to write 2 1010, okay, 3, okay, 100 picofarad plus C is equal to 300 picofarad, right? 100 picofarad plus C is equal to 300 picofarad. So C comes out to be 300 minus 100 picofarad, which is finally 200 picofarad. Option number B. Here is the option number B. Okay, so this is the very simple questions. Okay, in this question you have to conserve the charge. Okay, now coming to next question. Look at the question. A parallel plate capacitor was made with two rectangular plates, each with a length of 3 cm and breadth of 1 cm. Okay, the distance between the plates is 3 micrometer. Out of the following, which way to increase the capacitance by factor of 10? Okay, we have to find the final capacitance. Okay, what we have to write? For example, initial length is L and breadth is V. Okay, this is the parallel plate capacitor. Okay, initial length is L, which is 3, and final breadth is which is 1 centimeter given, right? Separation between the plates is 3 micrometer. Okay, so we know that the capacitance of parallel plate capacitor is nothing. C is equal to A epsilon naught upon D. This is the simple formula. Area comes out to be length into breadth into epsilon naught. Okay, upon D. And in this question, they have given that the final capacitance, which is C dash, is 10 times original capacitance C. So which combination we have to make? Okay, so we know that the capacitance of capacitor depend on this quantity. if the multiplication division of these quantities comes out to be 10, then it will be the final answer. So looking at the option, L is 30 centimeter, B is 1 centimeter, D is 1 mm, not possible. L is 3, B is 1, D is 30, which is also not possible. L is 6, B is 5, which is 6 into 5, 30 by 3, 10. Okay, now coming checking option D, L is equal to 1, B is equal to 1, D, not possible. Option E, L is equal to 5, B is equal to 2, and D is equal to 1. This will be also gives 10. So option C and D is the only option which is fit for this scenario. Okay, these conditions. This is also very simple question asked in JEE Main 2023. In this question, in the network shown below, the charge accumulated in the capacitor in the steady state will be. We know that in the steady state, capacitor is behave like open circuit, broken circuit. Okay, broken wire. Okay, so in a steady state, this wire will be broken and this capacitor is useless. Okay, so redrawing the diagram, figure 3 volt, 4 ohm. Okay, no need to be right, but let me draw 6 ohm. Okay, very simple. Okay, so first I have to find the potential across this capacitor. So I can write charge is equal to C into V, because C is the given, but we have to find the V. For potential, we know that this capacitor and this resistor and this capacitor in parallel. So potential across them is equal, right? So now coming to the potential across 6 ohm. So potential across 6 ohm can be written as V is equal to I into R. Okay, for I you have to write battery, potential of battery, which is V upon resistance. So resistance is R1 plus R2, which is R equivalent. I have to write V is 3, R is 4 plus 6. After solving, you will get 0.3. Okay, this is the potential. What is this is the current. What is the potential across resistor, which is I into R? So I is basically 0.3 and R is 6, which comes out to you 1.2. Okay, potential across this resistor is 1.5 volts. So potential across capacitor is nothing. It is also equal to 1.8 volt. Okay, so we know that charge is equal to capacitance into potential. Capacitance is given 4 microfarad. Okay, and potential is given. What is the potential is given? 1.8. So I can write 7.2 microfarad. That's the correct answer. Is there any option regarding this? Okay, 7.2, option number 4. Should I explain once again, or are you understand? Did you understand? Okay. Now coming to question number next. Capacitor of capacitance C is charged to a potential V, the flux of the electric field through a closed surface enclosing the positive plates. This is the plates of capacitor, this one is the positive, this one is the negative. Okay, the capacitor of capacitance C is charged to potential V, right? You have to write the flux. So flux is simply, what is electrostatic flux? Number of field lines passing through a closed surface. Okay, we can also write Q enclosed upon epsilon naught. Q enclosed is equal to CV epsilon naught. Option number first, CV upon epsilon naught. Okay, because on this charge plus CV and here minus CV, they are asking the flux through a positive plates. If they combinedly wholly ask the flux through the total plates, both plates, then the flux will be 0, right? Given below are two statements. One is a level assertion and other is level as a result. Two metallic spheres are charged to same potential One of them is a hollow and another one is a solid, and both have the same radii. Solid sphere will have lower charge than hollow one. Okay, that's not correct. Okay, having both metallic sphere charge the same potential, then both have the same charge, because potential depend on V is equal to kq by r. Okay, kq by r is the radius. Okay, it doesn't depend either the sphere is hollow and solid. Okay, capacitance of the metallic sphere depend on the radii of his sphere, right? Because C is equal to 4 pi epsilon naught r. Okay, if R is great more, then the capacitance is more. Okay, A is false and R is true. Option number D. Look the question number next. Next question. Two identical thin metallic sphere have charge Q1 and Q2 respectively such that Q1 and Q1 is greater than Q2. The plates were brought close to each other to form a parallel plate capacitor of capacitance. The potential difference between them is, okay, for potential you have to find the electric field. So we know that two thin metallic plates has charge Q1. This one is the Q1, this one is the Q2. Okay, respectively Q1 is greater than Q2. The electric potential were the plates were brought close to each other. Okay, so we know that we have to find the electric field. So electric field is equal to sigma upon F2 epsilon naught. Okay, sigma is that can be written as Q upon 2a epsilon naught, because this is the Q upon 2 epsilon naught, because sigma is the charge surface charge area density. Okay, so E1 can be written as Q1 upon 2a epsilon naught, and E2 can be written as Q2 a epsilon naught. And the question they have given Q1 is the greater than Q2, then E1 is greater than E2. So net electric field can be written as E net can be written as E1 can be written as, my friend, E1 minus E2. Okay, so Q1 by 2a epsilon naught minus Q2 by 2a epsilon naught, Q1 minus Q2 by 2a epsilon naught. Okay, this is the net electric field. Okay, about closer to each other, parallel plate capacitors, the potential difference between them. The potential is equal to V is equal to E dot D. Okay, E is equal to Q1 minus Q2 upon 2a epsilon naught. Okay, into D. We know that this quantity, which quantity? This quantity is nothing capacitance. Okay, this. So V is equal to Q1 minus Q2 upon C. So option A is the perfect. Right, by 2C. Option A is the correct answer. Okay, now coming to next question. Next question is very simple, my friend. Capacitance of an isolated conducting sphere of radius r1 become n times when it is enclosed by a concentric conductor sphere of radius r2 connected to earth. The ratio of their radii. Okay, so we need that if the r1, the capacitance is equal to 4 pi epsilon naught r1. Okay, becomes n times when it enclosed by a concentric conducting sphere of radius r2. Okay, so new capacitance, which is concentric two cells, because C dash n times C. So I can write 4 pi of capacitance of concentric cell. This is the cell 1 which has the radius r1, and this one was the second cell which have radius r2. Okay, or this one is the capacitance of radius r1, so capacitance will be C is equal to 4 pi epsilon naught r1. Okay, in this case C dash can be written as 4 pi epsilon naught R1 R2 upon R2 minus R1, right? So C dash is equal to simply nothing, it's a nothing. C dash is equal to 4 pi epsilon naught R1 R2 upon R2 minus R1, which is n times 4 pi epsilon naught R1. After solving all these things, you will get 4 pi epsilon naught R1 which. So final R2 by R2 minus R1, which is 1. If I write this quantity R2 minus R1, it take the inverse, then it will be 1 upon n. Okay, so 1 minus R1, in this question they are asking 1 minus R1 by R2, okay, which is 1 by n. Okay, so I can further write 1 minus 1 by n with R1 by R2. So n minus 1 by n, which is R1 by R2. In the question, what they had asked in the question, they had asked R2 by R1. Then again I have to take the inverse. Okay, right. So R2 by R1